Okay, we're going to learn how to solve radical equations. So we're going to start off very simple. The square root of x equals 9. And the easy way to think about this is that we want to raise both sides to the second power because this is the square root. Okay, so you got to remember that when you have the square root of something, the index is going to be a 2. They just don't write it, but it's understood. All right. So we're going to raise both sides to the second power because of that. All right? So we're going to raise the square root of x to the second power. And then we're going to raise 9 to the second power, because what you do to one side, you have to do to the other. Okay? Let me go ahead and write that in parentheses. Now, when you take the square root of x and you raise it to the second power, okay, that's kind of like saying the square root of x times the square root of x, okay, which is really the square root of x squared, and that becomes a perfect square, which is just x, okay. Another way you can look at it as when you have the square root of x raised to the second power, you can rewrite the square root of x as x to the 1/2 power. And when you multiply the exponents, 1/2 times 2 is x to the 2 over 2, which is just x to the first power, or just x. Okay, so when we square both sides of a radical, the radical falls out, and then we just write whatever's under the radical. That would be the quickest way, so we don't have to do all this on the right-hand side that I showed you. Okay, so when we square the radical x, it just becomes x. 9 squared is 9 times 9, so that's 81. So your answer is x equals 81. Alright? Go look at another example. Okay. Cube root of x equals -4. So what we're going to do is we're going to take the cube root of x, and we're going to raise that to the third power. Okay? And we're going to do the same for -4. Whoops. And we're going to raise that to the third power as well. And when you do that, the cube root of x, when you take the cube root of x and raise it to the third power, it's just going to be x. Okay? And then -4 times -4 is positive 16 times -4 would be -64. So the answer would be x equals -64. So remember, when you do this, -4 to the third power means -4 times -4 times -4. So when you do that, -4 times -4 is 16, right? Positive 16. And then you times that by -4, and then you get -64. So make sure you understand how to take the base and multiply itself. Watch out for the negative signs, okay? An odd number of negatives will always give you a negative result, okay? All right, let's do some more examples on the next slide. So here we have the fourth root of x. So we're going to take the fourth root of x, and we're going to raise that to the fourth power, because that's the index that we're dealing with, right? And then we're going to do that on the right side as well. So when we take the fourth root of x, it's just going to be x. And then 3 times 3 times 3 times 3 will give you 81. So just multiply the 3 itself 4 times, and you'll get positive 81. All right, so far so good. Now let's do something like this, where we have the square root of x equals 7 take away 4. Okay, so the first thing we want to do is simplify the right side by combining like terms. 7 minus 4 is 3, so you always want to simplify it when necessary. Okay, so combine like terms on the right side, and then now the index is a 2, even though we don't see it. So we're going to take x, okay, and we're going to raise that to the second power. And what you do to one side, you have to do to the other. So we're going to raise the 3 to the second power. Alright, so when we take the square root of x and raise it to the second power, it's just x. And then 3 times 3 is 9. Remember, 3 to the second power does not mean 3 times 2. It means 3 times itself twice. So be careful, okay? Alright, and that's your answer for that. Okay, let's do another one. So we have square root of x minus 3 plus 6 equals 10. So the first thing I'm going to do is isolate the radical, x minus 3. Before I can get rid of it, I need to move everything that's not under the radical on the other side of the equation. And in this case, we're going to subtract the 6. Okay? So we want those to cancel, and then you're just left with radical x minus 3 equals 10 minus 6 is 4. And now we can square both sides, remember? So we're going to square both sides to get rid of the radical. And all you're going to do is write whatever's under the radical. You do not need to FOIL it or anything like that. 4 squared is 4 times 4, which is 16. And now you have a very simple algebraic equation to simplify. Okay? So what we're going to do is we're going to add the 3 to the right side. So those cancel. Then you're just left with x equals, now 16 plus 3 is 19, and there you have it. There's your answer. Okay, so isolate the radical and then square both sides. All right, let's go ahead and do another one. Okay, let me just rewrite this a little bit better. All right, you notice that the 5 is not under the radical, okay? So we can go ahead and subtract it on both sides because you want the opposites to cancel. Then you're just left with radical x minus 4, and then 3 minus 5 is negative 2. And then we can do the step where we square both sides. When you square both sides, the x minus 4 falls under the radical, so we can just rewrite it without that. Negative 2 times negative 2 is positive 4, okay? And then I subtract, and then I add 4 to both sides, because you want to get x by itself, right? And then 4 plus 4 is 8, and that is my solution. Okay, so far so good, right? Okay, let's do another one. Okay, okay. So again, the first thing you should be thinking about is isolating the cube root of x plus 7, right? So we're going to subtract 2 on both sides. So then you just have the cube root of x plus 7 equals, now minus 1 minus 2 is minus 3. And now I can cube both sides of the equation. Again, the index is cube root now, so we have to do the cube root of both sides, not the square. So whatever the index is on that radical, that's what you do to both sides. Okay, so if it's the 4th root, you raise both sides of the equation to the fourth power. In this case, we're going to raise both sides of the equation to the third power, okay? And when we take the cube root of x plus 7 and cube it, again, it's just x plus 7. And then negative 3 times negative 3 times negative 3 is actually negative 27, okay? Now we can finally solve for x by subtracting 7 on both sides. So those cancel, then you're just left with x equals negative 27 minus 7 more is minus 34. And then that would be your answer. Okay. All right, I have more examples I want to show you. You notice that we have radicals on both sides of the equation, so we're not going to be able to isolate anything. So we're just going to jump right to the step of squaring both sides. Okay, so we're going to take, this was the original problem. Okay, and we're just going to go right to that step. Square both sides. And what you do is, the left side is just 2x plus 9. The right side is just x plus 7. And now we just need to get all the x's on one side and all the numbers on the other side. So I'm just going to go ahead and get the variable on the left side by subtracting x first. And that way you have 2x minus x is just x plus 9 equals 7. Okay? So that cancels. And then I'm going to subtract 9 on this side. So the 9's cancel, and I'll just have x equals 7 minus 9 is minus 2. And that would be my answer for that one. All right? Okay, and let's do another one. Okay, so here we're going to jump to the step where we're going to take the cube root of both sides. Right? Because the index is a cube root now, so we're going to cube both sides, and then the left just becomes x minus 7. The right just becomes 4x plus 11. Sorry, let me rewrite that. Sometimes the pen slips. Whoops. Okay, so now we have an equation where we want to get all the x's on one side and all the numericals on the other. All right, so I'm just going to go ahead and I am probably going to subtract 4x on this side. X minus 4x is minus 3x. Minus 7 equals 11. Then I'm going to go ahead and add 7 to both sides. So then I have minus 3x equals, and then 11 and a 7 gives me 18, right? Then I would divide both sides by negative 3. Remember, the 7's cancel here, the 3's cancel there. So that turns into a positive x, and this was negative 6. Once you get rid of the radicals, then it's just basic algebra of solving a very simple equation, a very simple linear equation. Okay? So really the most important part is isolate the radical when necessary. If it's already isolated on both sides, then just go ahead and take those radicals to the whatever the index is. So when you raise it to that nth exponent, it's whatever the index is. So if it's the cube root, okay, if the radical has an index of 3, and you take the cube root. If it's a square root, then you square both sides. If it's the fourth root, then you raise both sides to the fourth power. So the index is going to tell you what power to raise both sides of the equation. And that's really the main skill here. The rest is just basic algebra that we've learned before in solving linear equations. All right? And that's how you solve radical equations. Thank you for watching.